Cool. Hey, good morning, everyone, and thank you very much for making this the first session of your day. I think we have some really exciting stuff today for you. Also, there's a high likelihood that during the live demos, something will go wrong. That's always fun, right? To see us struggle on stage every once in a while. All right, let's get started. We're going to have 3 people on stage today. It is going to be, of course, Paul, my colleague, Abe, and myself. And we're going to be talking, number one, Abe will introduce us into what London Stock Exchange is doing with Azure and serverless in particular. And then we're going to go through a demo. There's going to be a 2-part series. The first one will be covered by Paul. The second one will be covered by me. And then we're going to do some Q&A if we have time. Let's get started. So this is an incredible portfolio we have on our hands, right? We can basically do everything from integration, data, to analytics, and of course, AI, and all of this would not be possible with all these services. So serverless does not exist without this larger ecosystem. And I would love to know, if I can see you, who in here is using Azure Functions today? And who in here is using Azure Container Apps? And who in here is using both at the same time together? All right, we got to change that number. And that's what we're here today. Yeah, so let's hand this over to Abe, and I'll come back in a little bit. Yeah.
Thank you, everyone. My name's Abhay. I run analytics engineering for the London Stock Exchange Group. And very briefly, what we do is we are a financial markets data and infrastructure provider. So you can think about stocks, bonds, any tradable security. We're in the business of collecting that from exchanges near real time, collecting data, any sort of data that a company needs, and then publishing that out either back to exchanges or to our clients, who are typically financial services firms. What do we do in terms of analytics? We basically try and price. What does that mean? If you have anything like a bond, you want to know what the price of that bond is going to be in the next 1 year, 2 years, 3 years till maturity. And there are various ways you can try to do this. One, of course, is a typical way where you have a closed form analytical solution. It's a mathematical formula. You plug in the inputs and you get an output. Another way is where you can run simulations. So you don't know what the future looks like. So you start running trials. So we run Monte Carlo simulations on a large scale, and we get an expectation of a value. We average that out, and that's your answer. Or the third thing we do is we look at our data. So that's machine learning. Traditional, typical, good old machine learning, where we sort of look at large swaths of data and then run regression models on it. That is basically what LSEG does at scale, and I'm here to sort of show you, like, amongst all of the things that Microsoft has and Azure has, we picked Azure Container Apps, Azure Functions for a particular slice of an application that I'll walk through now. So I don't know how much, I just wanted to give some context, but broadly speaking, if you look at this, we have users. These users are typically traders, they're typically investment bankers, or they could be retail traders. And what you can think about of this is we need to be able to price an instrument. So to do that, you need access to data. That can be real-time data coming in from exchanges like the NASDAQ, the FTSE, or our exchanges. It comes in, and then what we have is this concept of data preparation. So to be able to price a bond, you need to know things like what's your interest rate. You need to know what's your FX rate. So these are what we call market data. And then you also need to know the terms and conditions of a particular instrument. So you would probably want to know things like what is the maturity? What is the credit rating of the person selling this bond? So we get all this information, we plug it into our analytics, which is called quantitative pricing services, and that is then orchestrated across millions of tradable securities. Every client has a different flavor. Every client has a different need. Some clients will want to make an edge as to where they expect the market to go, and they want to place a bet on it. Some clients will want to protect against market moves, so they'll want to hedge against it. So based on that, we will value, and that's your middle box there. We will value based on inputs, and we will return results. Typically, there are 3 ways we do this. We have your typical request response. We have what is called asynchronous. So I have a million bonds, and I want to price it within 3 hours. You push that data in, and you'll come back after 3 hours. Or you'll do it via streaming or real time, where you'll basically, like you must have seen if you open up CNBC or something, you'll see the ticker at the bottom, right? So that's constant stock prices coming in. We do derivations on top of that. So we would give you constant streams of what are the options on Tesla looking like, for example. So those are the broad ways that we do this. And we have this is a typical microservice-based architecture where on the left-hand side, you can see the things we've chosen. And on the right-hand side is the sort of our infrastructure as code. This is all on Azure. We worked significantly with Microsoft engineers. LSEG is in a strategic partnership with Microsoft, and we are using Microsoft to build out our new data platform. And the reason for us moving our analytics to Microsoft and on Azure is because if you want your compute to be as close to where the data should reside. You don't want your compute far away and then your data somewhere else. So we always want to push down our analytics as close to where the data is. And so we decided, we went through architectural choices, and then we picked up Azure Container Apps, and this is how we deployed it. The last thing I'll end up in is we talk about HTC, or high throughput computing. This is something that I just wanted to showcase and just quickly walk you through this as why, in terms of the scale and the speed in which we need to do this. So we're talking about, say a few milliseconds to tens of milliseconds. When we need to be able to, given a tick, we need to be able to respond with a price. And with that, we need to be able to get a request in. We create a job. This is your typical queue. It comes in. And on the right-hand side, we scale out. We have hundreds and hundreds of microservices running that pull stuff off the queue, and then we price it and push it back onto a queue. It's a simple architecture, but the devil's in the details in terms of we have clients who are spiky. So some clients want streaming data. Some clients want something that is consistently with, and so they want to depend on every tick, so they want stable. Some clients want spikes. And we have to sort of be pretty clear in terms of what we do, how we do it, and what architecture we choose to be able to scale. Where are we in this? We have migrated to Azure. We're running in production. Clients are being cut over, and it's been a success story so far. And I really want to thank Microsoft for allowing us to try this out, and it's been cool. So thank you, and I'll hand it over to Paul, who runs Azure Functions at Microsoft. Thanks.
Hey.
Thank you.
Hey, everybody. Good morning. I'm warning you, I feel like I've had Red Bull this morning, so I'm going to be a little feisty. I'm really excited to be with you. I'm Paul Yuknovich. I work on Azure Serverless with the gang. Let me get my bearings here. OK, so we just saw a really cool solution where a real partner and customer is using the serverless platform, Azure Container Apps, Azure Functions, and a number of supporting services for data to really build a critical solution. It's one we all depend on. Like you mentioned, on the TV screens, we all use and depend on this kind of a solution. So we're going to walk through in the next few minutes. We're going to just talk about some of the updates we've made and also see in a demo, and it's one that you can take home and kind of follow at your leisure, really the same thing, how we're going to bring a big corpus of data together, use container apps, use functions, and really build a complete solution. So very excited. There's a number of announcements you might have seen in the last 24 hours spanning Azure Container Apps and Azure Functions. Yeah, this is a great one to take a picture of. I'm going to encourage you, go check out the blogs. Go talk to the experts this week if you have access. Talk to us online. There's just too much cool stuff to cover. I'm going to really focus right now on some of the front end of the solution that you can use, and Simon's going to take us home with the rest. Okay, so first thing, I'm very excited. This has been a long time coming. I'm excited to announce the general availability of Azure Functions Flex Consumption. Yay! Thank you. The engineers sitting over there, they need to hear that too. So this is really the hosting plan I am most excited about in the history of Azure Functions, because really we're going to get that flexibility of scale. What I mean by that is we can burst incredibly fast, like I call extreme scale. We can go hundreds of instances of workers in seconds. We can do 1,000 in under a minute. You can scale to 0, you can scale to a lot, and back and forth. So it's really going to help you with those elastic workloads, and it's just going to keep up with the kind of demands you're pushing. Also, no apologies, no compromises. Not only do you get the scale, but you're going to get the full suite of private networking. So I mean by that, you get VNets, you get private endpoints, DNS zones, all the kinds of things we need to do to build a modern, compliant, absolutely secure, and network-isolated environment. So in the past, you've seen, we have serverless, and then we have other offerings with private networking. Now you get it all together where it belongs. And then, of course, this is serverless. That's the big theme of this whole session. The way I think about that is your billing, your application is just pay as you go. You pay literally by the gigabyte second of your app executing, and that's it. So you can be incredibly efficient. When you're having a lot of load, you're having a lot of interaction, that's when you pay. And when you're not, you don't pay. So that's kind of the beauty of this whole thing. We have a customer and a partner that has been working with us on this journey with Flex Consumption. That's GitHub. I think we've heard of GitHub. Their app is, the app that uses Functions is really their telemetry system. So you can kind of think of the massive amounts of GitHub users, the massive amount of telemetry that gets produced. All of that telemetry ingestion coming from the GitHub app goes through Azure Functions using Flex Consumption. And it's also in participation with Event Hubs and also running in a VNet. They have the same security needs that you do. And they're able to sustain that 1.6 million transactions per second, 1.6 million messages per second. Totally awesome. If you look at the chart, what we're actually seeing is kind of the message queue age. Like, the more messages, that means the less you're keeping up. So what we're showing is as soon as Flex Consumption starts chunking on this, it just brings that queue age right down. And then we're able to sustain it. So it's just been awesome, and GitHub has really helped us prove our mettle and make sure that Flex Consumption is ready. So, by the time we've GA'd, we've been running gigantic workloads through this thing to make sure it's ready for all of you. One of the most special things, in my opinion, about Flex Consumption is the fact that we uniquely give you concurrency control. I have to admit, when I came to serverless, I had to learn a bit about concurrency. What it means to me is the number of concurrent or parallel events I can consume per instance of a function. So if I have concurrency of 1, or concurrency equals 1, that means I have exactly one worker handling exactly one event. Which you can imagine, you're throwing the full horsepower, the full CPU, memory, I/O resources of that function at that one message. And you can rely on our scalers. So if you have more messages, if you have thousands of messages, we can give you 1,000 instances. So no matter what your code is, we are going to help you scale out with that. But this is where it gets special. You can also set the concurrency higher. So if you're confident that your code works well async, it works well concurrently, it's thread safe, you're not going to get deadlocks, then you can throw a lot more messages at the same instance. So here I'm showing concurrency equals 2 on the bottom right. And that actually means that one worker is going to process 2 messages in parallel at the same time. You can set it to 16. You can set it to 50. I'm going to show you that in the demo. But this is really special. And I think the bottom line is it's going to help us build more efficient and even faster applications taking advantage of concurrency. I'm going to switch topics to AI. So we've seen a lot of exciting things about Azure AI and Azure Foundry over the last day. And I want to talk a little bit about how Functions has fit in. So Functions, even without updates, has always had some superpowers in the domain of AI because AI starts with a lot of data ingestion. Think about those RAG scenarios. Think about all the data that comes in to infer models and to do training. People are using Functions for that. It's just an incredibly easy, scalable way to do it. And we have that programming model with the rich triggers and bindings, whether it's queues or blobs or whatever, like we can really ingest that. And we also have some even more special features I'll show you, things like durable functions, which make it really easy to orchestrate and chain a number of actions or a number of activities together and give you that resiliency. So if any one thing fails, we can retry, and you don't have to write all that journaling, event sourcing kind of code yourself. So that's what we do. But what we also do now, and I'm excited to say, is we have a preview of an extension of triggers and bindings for Azure OpenAI and Azure Foundry. And the most kind of cool thing, in my opinion, is that we can help you with function calling. So if you saw yesterday, Scott Guthrie talked about, there's actions. That kind of means you're going to register your custom code with Azure AI. And when certain prompts come through, you're going to call your custom code. And it really allows us to extend and go way beyond what an LLM, a model, can do. It also lets us cover use cases just unique to our business domain. Like, hey, I'm going to fire off tasks. I'm going to orchestrate some things. I'm going to do downstream processing. So you can extend AI completely with these actions and scaling assistance. And then also, the extension will help you do things like RAG with completions, things like embeddings. And just, Azure Functions always is kind of there to make life easier, and it's going to make those things easier. So that said, why don't we do a demo? This demo, who here likes baseball? Any baseball fans? Okay, well, if there's other sports you love, just take a $20 bill, just give it to me after this, and we'll change the demo for next time. This time, we're gonna do baseball. And there's a whole bunch of data. Actually, my friend and colleague Simon got this immense amount of baseball data with CSVs. And in this demo, what we're gonna do is we're gonna ingest all of it using some functions in the front end. And then we're going to basically chat our data. We're going to chat our data with a rich static web app that's calling into a function with a chatbot. It's using the triggers and bindings. And it's also going to use these actions. When we see anything about baseball, we need more powerful models. So I'm going to leave that for Simon. But he's self-hosting way more powerful models on container apps with GPUs. And that's going to make all the magic happen. So this is a complete solution, actually spanning container apps and functions. The QR code and the link will take you to the demo. Follow along at home. All right, so that said, let's close PowerPoint for a second, which I always love to do. It makes me happy. Let's go look at some code. So I'm going to switch over, seeing it on the screen. OK, awesome. OK, so what we have here, we have the code that backs that kind of architecture diagram I just showed you. There's services in the front end. So I have this UX app, and I have the app that's going to upload data, and I have the app that's going to orchestrate kind of like big batches in parallel of data. And then on the back end, Simon's going to cover it, but he's got his microservices on container apps that are going to interact with the more special models. And what really fuels this thing is the assistant skills file. Let's pop into Zen mode. And so what this file is going to do is, we've just got a main function that's the star of this, an ordinary code function, get baseball stats. And what this is going to do, this custom function that I wrote is going to plug in to the model, and it's going to extend the model as an action, okay? And so just by having this, this kind of decorator attribute, assistant skills trigger, in the functions programming model, that's all we need to do to register this custom piece of code, which can be anything, it's your code, that'll interact with the model. And then in this case, what I'm going to instruct it to do is any baseball question, and I give it an example, any baseball question, I don't want the model to handle it because it's not going to do a good job. Instead, I want to handle it in this code and actually delegate to Simon's custom code. And you can see here, I'm making a post off to his microservice, and that's where we're going to do the heavy lifting. So this is assistant skills, and it lets us do actions. Let's actually kind of check out the app. Okay, so we're going to pop over to the browser, and we're going to make this bigger. Okay, so here I'm going to look at just real quick at the resource group. So I've deployed this application, and you can see all the microservices, right? We've got the container apps. Let's sort it by type. We can see the container apps, and we can see the Azure functions. That's doing the heavy lifting. And another thing I'm just going to call out, besides the static web app, we have, let me remember the hotkey. Everything here is on a virtual network. And one thing I'm really excited about is everything is on the same virtual network. So our container apps, our functions, and all the storage and other dependencies, all on the same VNet, and all set up with best practices for network isolation. So every single app-to-app and app-to-dependency interaction is set up using a private endpoint. This was not possible before. We're really excited to see the whole platform come together and enable this like secure scenario. Yeah, thank you. All right, and so that said, let's check out the static web app, right, which we go here, and I've already preloaded in a tab, because I want to be fancy. So, first thing, let's just do an ordinary question that has nothing to do with baseball. So like, what is the airspeed velocity? This is a very important question of a swallow. You're catching on. Oh, yes. So I think it needs some clarification. No, a European swallow, or I should say an unladen swallow. Okay, awesome. And so now we have the question we were all burning to know, the airspeed velocity of an unladen swallow from Europe. And this is just using ordinary LLM model, right? So this is based on kind of the world's Family Feud knowledge of data. But this has nothing to do with my custom domain data. So let's actually do something a little bit different. Let's say, got to remember for inspiration, maybe like what baseball players were born in the 1800s, just like it's saying. What were the baseball players born in the 1800s? Simon, you'll have to keep me honest. Hopefully I'm asking good questions. All right, and again, it's going to delegate to Simon's microservice in its infinite glory, and it's going to give us a more custom answer. It's too soon for the uh-oh. I heard that. Okay, maybe not too soon. We'll give it another second. This is real demos, though. There's no videos here. Oh. It's just telling me I should probably do this. How about from the 1980s? Maybe that's a more sane question. Did I just do a full range scan? Yeah, I did. Sorry about that. We could always blame the database. That's what developers do. Okay. We learned about swallows. We want to learn about some baseball. All right. Well, if it's kind of going like this, maybe when we get back to Simon, you can, have faith. Okay, so here we go. Yeah, thank you. All right, because that went so well, why don't we push the limits, Simon? How do you feel about that? So how about what was the average salary for players from 1980? So we're going to get more specific. Remember, the assistant skills trigger actually remembers the memory. Okay. How about which players from 2015 were above the Mendoza line? You know what that is? That means they're batting above 200. Come on, give me good vibes. Did I mention? I'm calling a microservice in Australia. Okay, well, we will be redeemed, don't worry. Okay, so I'm going to come back. We're going to shift gears. Let's talk a little bit about the scale. I promised you all some like real extreme scale. How about we take a look at that? So let's come down here. All right, so there's a different file I'm going to focus on. So we're going to go to the source code for uploading data. And the star of this is actually a Python function. So we're going to diversify a bit here today. And we have this upload data set of functions. I have one that takes a single line from a CSV, and then I have one that takes a gigantic CSV and is going to chunk it up. Let's focus on the single case at first, all right? So we're going to take a line of information about our baseball players, and what we're going to do, I like to follow an asynchronous pattern. So we're going to take an HTTP post in, and then we're going to tee that up as a service bus queue message. And then we have other services that can take that off of the queue and kind of orchestrate some processing on it. Who wants to see me like prove the extreme scale? Anyone in the room? All right, so let's do that. What we're going to do, we're going to pop over to this load test, and that lives in the upload in the test folder. And so we have this simple CSV. Again, as promised, it's one line. But I'm going to do a whopping load test on this, big one. So let's make this a little bigger. And we'll refresh our live metrics view. So one of my favorite features that we work with monitoring and App Insights, and they have this live metrics view. And this is really cool to see the scale. So we're going to watch the requests coming in, and we're going to watch the server instances. We'll just let that warm up. OK, what I'm going to ask you all to pay attention to as we do this is we're going to watch the request rate, and then we're going to watch the number of servers. Now, just because I'm monitoring in a web browser, I've actually triggered some functions to run. But it'll be 0 if you're not monitoring it with a live connection. All right? So we're going to go back to our code, and we're going to run this load test. And this is just going to use a command line tool called plow. And we're just going to force some load right here, right now on this very machine. All right? So you can see it's really flying with some load. Now let's go back, and let's zoom in a bit. So let's watch in real time. We're going to watch the server count, and we're going to watch the request rate. There we go. Watch that. Look at that. So as the load is steeping up, it is flying through the instances. Like this used to take minutes. Now we're literally in seconds up to the 240s, like what, 254, 260. Nice. And look how smooth Flex is just kind of crushing that request rate. So you know what this means for you, we're going to be able to handle your intense loads. And another thing, too, that I'll call out, you know, when I do load tests like this, I do like to look at how well am I using my resources. You can actually see here the CPU and the committed memory use. Like, I know I have a 2 gigabyte machine. I have plenty of CPU power. I feel like this thing could use more. So maybe in this case, I've actually over-provisioned. Like, I handled the throughput. I met my first goal. But now I want to be incredibly efficient. So we have another feature that I'm excited. Actually, let's kill this load test. Let's do that real quick. OK. And we're going to come back here, and we're going to go to the function that's handling this. So the upload data function. And every Flex consumption function now has this integrated performance set of features. One that does load tests, and one that uses load tests to do performance optimization. And basically what this is going to do is let me kind of configure a few different load profiles and help me right size the actual function kind of in real time. So if I look here, I have a load configuration. We'll zoom in. I'm going to choose that 2 gigabyte SKU, but I'm going to try a concurrency of 1. Remember, that's maximum scale out. A concurrency of 10, so 10 per worker, and then actually 50 per worker. We're actually going to compare them side by side. I'm going to go over to the actual live results. This is me doing the cooking show, pulling it out of the oven. You don't want to see me run a load test for 45 minutes. So here's the actual result. Oh, wow, and the screen's so excited it's blinking. Okay, sorry about that. And the thing I want to call out is that we were able to actually achieve the throughput we needed at all times. So amazing throughput, but actually, as I dialed up concurrency, a really cool thing happened. We actually saw the latencies and the response times go down. The reason why that is, we have code that was written in an async way, and it's really well suited to run in parallel on the same process. So we had those pre-warmed instances taking more, and we were actually able to handle a lot more load. So I think the bottom line is, with flex consumption and the concurrency control, you can be more efficient, actually save money, and actually improve that in performance. The last thing I'll say, we have a feature in here called durable functions. And durable functions, I'll kind of leave it as a kind of an exercise for you guys. But we have this really special durable function. Right here. And the really cool thing that this is doing after it initializes is it's going to go through this orchestration workflow, and it's going to chunk up or batch a set of parallel tests. So it's going to chunk up this gigantic file into smaller chunks, and it's going to call other microservices all in parallel, and then it's going to asynchronously await all of them being done to know that the workflow is complete. And it might be scary to do all these, it's called a fan out. So we're doing a fan out of all these things in parallel and then doing a fan in. But durable functions will actually do the state management and the journaling for me. So this is completely reliable. And if any step fails, it actually has built-in retries and all that kind of state management that you don't have to do yourself. So I'll leave that for you to go check out. And we had some fun anyway. I'm going to hand over to my friend and colleague Simon, who's going to take us home. Thank you.
Thank you. So I have to take the blame for what happened to Paul because, well, it's my endpoint that didn't work. We'll debug this here live on stage if my laptop wakes up. And yeah, well, we'll find out. Anyway, let's dive into what we have with Azure Container Apps launching. The big launch today, or yesterday as a matter of fact, is of course Azure Container Apps' serverless GPU. I think anyone who has been using serverless or in combination with Azure Container Apps has found it to be extremely powerful. This brings the same power to GPU use. This makes GPUs really easily accessible, and as a matter of fact, we made them really easily accessible, and actually I want to kick that off with that to actually show you really easily, because not a lot of people are like, what do I do with GPUs? Like, how do I use those? How do I get started? And so I'm going to walk you through some of this really quickly at the beginning to show you how easy this is. So here I am in Azure Container Apps. I'm going to just kick off a new app. We've been busy, as you can see. Just going to launch a GPU instance to show you guys how easy and quick it is, and then we'll revisit that at the end. And hopefully this loads. Maybe it doesn't. Let's help it. As a matter of fact, all right, well, maybe we'll come back to this. Maybe we come back to this. Yeah, well, let's go back to the slides. Nope. Yeah, good call. That's also what happens when you step away from your laptop for 30 minutes and then come back and everything has to page back in and whatnot. But we are going against Australia East, so that probably has something to do with it as well. I checked if I'm, yeah, anyway. Let's move back to the main screen and see what happens here over the next. All right, and so who would want to use serverless GPU? Why would you need this? We all have been experimenting with AI in one way or another. The easiest way to do that and get started, of course, are APIs, right? So we use also sometimes referred to as models as a service, right? But if you kind of are in day 2 or you work in a sensitive field like healthcare or finance, like Abe does, oftentimes you have your own models and you want to make sure that those don't get out of hand because it's essentially your data. And so you want to run that on your own kind of compute. Up to this point, you really only had 2 choices, either on the left-hand side or the right-hand side. You either use the right, models as a service, or you use left, where you basically reserve your instances and then they become yours and you pay for them regardless of whether or not you're using them. With serverless GPU on Azure Container Apps, you now have kind of the best of both worlds. You can run your own models on your own compute and only pay as you go, just like any other consumption. With that said, let's see, yeah, there you go. So I'm going to switch back over to this. There we go. Come on. Oh, this is going to be fun for the rest of the day. Come on. The portal has loaded. So we're going to kick off this, this container app really quickly. I'm going to deploy into the same environment. I'm actually going to go and pick GPU, and why not use the big, since we lost time doing the other stuff. And actually, I'm just going to use the quick start image with GPU. And then we're going to create and kick this into gear. And there we go. All right, now we're going to switch back. I'm running behind if you can't tell. All right, next, I want to talk about dynamic sessions. And there's a white slide. There it is. OK, so dynamic sessions. Who here has heard of Azure Dynamic Sessions before? OK, I really recommend you guys check this out. It is probably one of the most exciting services that I have played with, and we're going to be playing here with it at the very end as well. It is essentially an enclave for untrusted code. A lot of LLMs generate code. We heard it from Paul here earlier. The baseball agent actually generates code as well. And so the idea is you don't want that to run anywhere in shared memory with your other applications. So Azure Container Apps' dynamic session gives you an endpoint that you can essentially execute your code in, and it's completely isolated in its own container and separated by Hyper-V barriers. So it is the safest as well as fastest way to run any LLM-generated code, but can also be used for other things like live documentation, ingest, or any of that stuff. And actually, you might have actually already been using Microsoft you might have been using this through Microsoft Copilot. Actually, we have about sessions supports about 400,000 sessions per day. If you go and ask Copilot what 1 + 1 is, the chances that that gets actually shelled into a session and executed there are very high. So we're using this already at massive scale. And then today, we're also launching sessions for Node. Currently, we have sessions for Python. We're launching it for Node. Also, for you that are using container apps, we're launching maintenance windows for our dedicated profiles. So if you're concerned about any upgrades taking place while your application is under peak load or anything, maintenance windows will solve that for you, as well as private endpoints. And so let's go into the second part of this demo. My laptop did not go to sleep this time, so that's good. So we just deployed this. Let's revisit our app. I don't think I actually enabled Ingress, which is a big mistake. Oh, I did. Boom, and serve this up. So we deployed this earlier, and let's see if this comes up. And I'm actually going to load while this is loading the other piece. So I have to dive into this demo one more time. Actually, if we kind of remember, Paul's failure, as I have learned, actually, or the baseball agent's failure, as I have learned, actually, building this demo, structured data is really, really terrible for LLMs to be ingesting. It is unlike RAG, which we are probably all familiar with at this point. It actually uses a system or a pattern called text-to-SQL, or the more advanced pattern is TAG, table augmented. And so what happens is the query that the LLM generates or drops off, in this case from Paul, gets then translated into a query and gets run against the database by the LLM. The results get returned, cleaned up, and then returned to the calling endpoint. As you might imagine, this is all fully dynamic. So we're building these indexes and basically informing the LLM about what the structure of the table looks like, and then we hope that the query is right. In a demo scenario, of course, that is not a production-like scenario. So we are dealing with essentially schemas that are all varchars instead of integers and dates and probably parsed. And so we ran into issues there. But I'm actually going to go and be brave enough to try this thing again. So this is the endpoint of the baseball agent itself. I'm going to just use the Swagger because I don't have a fancy demo like Paul. So just going to kick this into gear here. And I am going to ask, did we do the average salary? We tried. Yeah. Salary, hold on, salary of players, players in the 1980s. And I'm going to make sure, well, screw it. Let's find out. So you can see the result is right here. Whoop-de-doo. It does not look very pretty, but it managed to actually run the query. We could keep going on this, but I actually also want to show you dynamic sessions in action. So let's kick back over here. I have just a very short, small demo. This is actually also utilizing the model endpoint that we're running in ACA as well. You can see it's loading and listing us the models that are available on the endpoint that are running on serverless GPU, and it loaded one of the models up. And I'm going to just try. There's essentially absolutely zero guarantee that any of this will work because I put this together literally while I was on stage up here earlier this morning. So we're going to see if this works or not. But the idea is basically, again, perfect. 1 + 1 is 2. Great achievement. But let's see if we can do something else. I'm going to be getting really brave now. We can see this basically then, the reasoning loop, right? So in here, the pink is one piece, and and so on and so forth. We're going to try this and kick this off. This might or might not work. It doesn't have a website. Anyway, so I want to finish this out. I think you saw today that you can use Azure Serverless to empower developers and not to control them. We deliver at any stage. Doesn't matter if you're early or massive scale. We deliver for any application. It doesn't matter if it is a lift and shift, completely serverless, or re-architected. And we do so without any hassle or any maintenance. And we hope all of you use more of Azure Serverless. That's it. And we're around for Q&A now, and then also later as well.
Thank you, everybody. And we were
All right.
redeemed on that.
And we were redeemed.
Yes.
Let's see.
I'd like to think so.
Yeah. And this one came up too.
All right.
Look.
So I think there's a couple mics if folks feel comfortable asking questions. We're up here in the front. Totally up to you. So we're in the unstructured part of the session. Thank you.
Oh, yes.
Yeah, so
Yes, actually, if you want to
Repeat the question.
play with any of the tech that you saw today, at least either functions or, thank you for the reminder, or Azure Container Apps, go to lab
search
413, lab 413 and
409.
409 for functions, yes.
Yeah, there's one tomorrow. And we're also
And-
hanging around at the expert serverless booth the whole time.
And you remember we set this app up earlier and it didn't load quite in time, but it is as easy as this to actually get your own image inferences. And that was not planned. So I'm going to switch away because people might text me more nasty things in the next 30 seconds. Cool.
Cool. Okay.
Thank you all for coming.
Thank you.
Yeah?